Okay, so this is objective 8.2b. Today we're going to start graphing the trig functions. Okay, so today's topic is the graphs of the cosine and the sine functions. And your objectives: graph the cosine and sine function and identify their properties. So let's develop some vocabulary here really quickly. Just make sure we're speaking the same language. You know how trig is its own language. So let's remind you of a continuous function. Continuous function is a function on a graph that creates one continuous curve with no discontinuity. No breaks, no holes, no asymptotes. Okay? A period. A period is the distance on a graph that it takes for a function to repeat itself. So you'll notice over here I've drawn a graph with a wave that's just continually up and down. So you can see a pattern that repeats and repeats and repeats. So the period is the distance on the graph it takes before the function repeats itself. I typically like to look at this from peak to peak. That's usually how I'll measure a period. You could also do the trough to the trough, which is just the bottom. You could go trough to trough if you'd rather. So you can see down in blue down here at the bottom. This is also the same distance, and there's your period. Okay, so you just see these values repeat over and over again. A periodic function is a function that repeats its values, and let me be clear, those are its y values, okay, over regular intervals. And the sine and cosine functions are periodic every 2 pi radians. And you watch that on the unit circle as you spin around. Your cosine functions repeat and your sine functions repeat. And when we graph it, you'll really see it happening. Okay, the next term here is an even function. An even function is a function that is symmetric about the y-axis. So there's the definition underneath that. I have the algebraic equation to represent it that says if I plug in a negative x, it gives me the same result as if I plug in a positive x. So the y's will be equal regardless of what the type of x I plug in, positive or negative. And I'm going to zoom in here to the picture just so that we can look at it a little bit better. Over here on the picture, I'm going to try one more time. So let's look at this picture here that I have. You'll notice that I have these 2 points indicated here at the peaks. This is a value of negative or positive x, and it's up y. And this is the same distance, negative x, and it also gives me the same output, up y. So you can see the symmetry there. And the same thing would happen if I'm talking about this point. If this was my distance, negative x, then I'd go down, that's a negative y. And if I go positive x to here, I'm going down to negative y. So symmetric across the y-axis. FYI, the cosine function is an even function. Cosine is even. Okay, then we talked here about an odd function. An odd function is a function that's symmetric about the origin. So what happens with an odd function is, if I plug in a negative x on the left, and I plugged in a positive x on the right, plug in a negative x, it'll give me the opposite y value. Okay, so what happens is you have a reflection across the origin. So if you look over here at my picture, these green points are symmetric about the origin. You'll notice here, I'm going to grab my pen real quick. This is a positive x value, yes? And it produced a positive y value. And over here, I went negative x value, and it produced in quadrant 3 a negative y value. Do you understand that? So when a function is symmetric about the origin, whatever points you graph in quadrant 1, you reflect to quadrant 3. And whatever points you graph in quadrant 2, you reflect in quadrant 4. I like to say that odd symmetry is rotational symmetry. If I were to take this picture and rotate it 180 degrees, all of these points would be over here upside down. They would. Okay, so that's odd symmetry. Also, the sine function is odd. All right, and then the last one I wanted you to squeeze in there was amplitude. So when we're graphing a sine function or a cosine function, we like to know how high do we need to make this curve or how low does it need to go. So amplitude is the half the distance between the peak and the trough. So I like to talk about this as the midline. It's the distance from the midline to the peak, right? Because the midline would be half the distance. So you'll notice, or you could go midline to trough. The point here is you need to remember that amplitude is always positive. It's a distance, so it's positive. So you'll see over here I drew a cosine wave, and I put my midline in here on the x-axis, and the distance between the midline and the peak is 1, and the same distance going down from midline to trough. It's a distance of 1. So your amplitude is the midline to the peak. It's just that vertical distance. Remember, always positive. Okay, so now we're going to graph the cosine function because I told you earlier it was your lead function. But what I think we need to make sure everybody's really clear about, listen to my words. This is the f of theta. Remember when we plugged it into the calculator, we had to plug in x. So our input is going to be our angle measure, and our output will be the cosine of that angle measure. Okay? So input is theta, output is the cosine of theta. So theta will be our x on the graph, and cosine will be our y. Okay? Now, I think it's nice to be able to use your unit circle or your reference sheet. So I drew a little unit circle over here with just a reminder that cosine of theta is your x coordinate, right? Yes? And sine is your y coordinate. Since we're graphing cosine x or cosine theta, we'll be using the x coordinates as our cosine theta values. And I think I'll come over here and just put a little circle around that because I forgot to highlight that. Okay, so first let's work on our axis or our quadrantal points. Let me zoom out a little bit so that you can see, or so that I can see the whole thing. I wish the shortcuts worked on this and I didn't have to do this, but they don't. It's really frustrating. Thank you for your patience. Okay. I can scroll back and forth. You good? So let's start at 0 radians. Okay? So at 0 radians, what's your cosine of 0? 1. Right? 1. Right? Because you just look at your coordinate for 0. Right? All right. How about at pi over 2? Pi over 2 radians, the cosine of pi over 2 is 0. Right here. 0. What about at pi? Pi radians, the cosine of pi? -1. Okay, now we're looking for the cosine of 3 pi over 2. So we go to 3 pi over 2, 0. And then at 2 pi, we're back. So you see the period? You see what happened? We went from peak to peak. We went from 1 to 0 to -1 to 0 back to 1. Then we're going to go to 0 to -1 to 0 back to 1. Let's go in reverse. So let's go from 0 to negative pi over 2. Are you ready? I'm so glad I don't have to move the paper back and forth. Here we go. So negative pi over 2. What's the cosine of negative pi over 2? 0. Rotate back. Negative pi. So the cosine of negative pi? -1. Cosine of negative 3 pi over 2. And then the cosine of negative 2 pi? 1. So if you look at that pattern of points, notice it's just a repeating pattern, right? Okay, so how about we graph those? Let's just graph those. So at negative 2 pi, we're up here at 1. And at negative 3 pi over 2, 0. Negative pi, negative 1. Pi over 2, 0, 0, 1. Pi over 2, 0. Pi, negative 1. 3 pi over 2, 0. And 2 pi, 1. Okay, now, if I were to graph that right now without putting any intermediate points in there, I could connect those with lines. But the cosine function is a curve. So we need to put some intermediate values in there so that we can get the curve, the gist of the curve. So this is why I chose the 45-degree angles or the pi over 4s, because what we just did is we did every pi over 2, we found a value. So let's cut that value in half. So let's go to pi over 4. So pi over 4, let me get my eraser here. Pi over 4, the cosine of pi over 4 is square root of 2 over 2, right? But here's the problem. I don't know where that is. So we plug it into the calculator and we get an approximation of 0.71. Okay? So every time we see the square root of 2 over 2 or negative square root of 2 over 2, we're just at positive or negative 0.71. So here we have there. Okay? Now let's go over to quadrant 2. Now is cosine positive in quadrant 2? No. So it should be, and you can see it, it's negative 0.71. If we cruise around to quadrant 3, is cosine positive in quadrant 3? No. So it's still, and if we cruise all the way around to 7 pi over 4, cosine is positive in quadrant 4, right? All right. So there's your positive rotations. Now let's just rotate negatively. So we're going to go from 0 to negative pi over 4. So that's there. So we're in quadrant 4, where cosine is positive. Rotate back to negative 3 pi over 4. We're in quadrant 3, and that's negative 0.71. Rotate back to quadrant 2 at negative 5 pi over 4. Cosine is still negative. And then rotate to quadrant 1 at negative 7 pi over 4. And we are back to positive. Well, I think what you could notice here is that this point was coterminal to that one, so they were the same. They had the same terminal side. This point, and this point. They're coterminal, so they're going to have the same trig values. Right, so let's graph those. So I think I'll just start right here at negative 7 pi over 4, and we're about right there. Just give it a go, you know. At negative 5 pi over 4, we're down here. And at 3 pi over 4, we hit the valley, and now we're headed back up. At negative pi over 4, we're back at positive 0.71. Then at pi over 4, we're headed back down to 0.71. 3 pi over 4, we're at negative. 5 pi over 4, we're at negative. And then at 7 pi over 4, we're back up at positive. So you can see through the points that we've graphed that you've got a nice curve going on. Let me just caution you. I have seen so many times people draw the cosine function, and on the end behaviors, they draw it incorrectly. So this is a peak, right? That's as high as this goes, right? So what you need to do is indicate on this side that you're headed back in a downward direction, and then curve through your points. This is going to be a challenge for me. I missed a point, but just go with it. And do you see that this is an even function? Symmetric across the y-axis. When you get to 2 pi and you hit the peak, bring it back down to indicate that that is going to drop back down. And there you have a sketch. It's a pretty good sketch. Not accurate, but good enough, of your cosine function. over the interval negative 2 pi to 2 pi. Now remember what your homework is to do, is to sketch the cosine function over the interval 0 radians to 4 pi radians. It'll look just like this, except that you're going to have to extend it out to 4 pi. Okay? All right, so let's look at some of its properties now that we have drawn it. Give me some features. Is it continuous or discontinuous? It is continuous because there's no angle I'm not allowed to choose. I'm not restricted from graphing any angle. What's my domain? Domain. My x-axis is unrestricted. I can pick any x I want, any theta I want. But my range is very restricted from negative 1 to 1. Is it open or closed? It's closed because we're including negative 1 and 1. But it's going to bottom out at negative 1 and top out at positive 1. We've already talked about it being even. So its symmetry is across the y-axis. All right. Now, let's measure its period. Remember, period is the distance for one piece of the pattern. Before the pattern repeats, the pattern repeats. So let's look from peak to peak. So here's a peak. Here's a peak. What's the distance? That's right. Cosine function has a period of 2 pi. And then everything starts over again. Lastly, what's its amplitude? So we go back up to the picture. Amplitude, remember, is the midline, distance from the midline to the peak. So would you agree that the x-axis is your midline? So the distance from the midline to the peak is 1. So it has an amplitude of 1. All right, very good. So that is your cosine function. Before we move on to the sine function, I would like to clarify anything. So if you have questions, please ask them. Okay, then on to the sine function. So here we go. So you'll notice again that I've drawn, I just copied and pasted my other one, but this time I've highlighted my y's instead of my x's, because remember on the unit circle, oh, I'm switching to red as well, so let me switch to red. So my cosine of theta is my x value, and my sine of theta, well, that's my y coordinate. I'm sorry, I should be talking in coordinates. Cosine of theta is the x coordinate, and sine of theta is the y coordinate. Okay, so back to the picture. Let's start at 0. Actually, I think we could start at negative 2 pi, right? That would be right here. What's the sign at negative 2 pi? 0. Then let's just go back to negative 3 pi over 2. Negative square root of 3 over 2. I'm right here. It's positive 1. The sign of negative 3 pi over 2 is positive 1. Let's go back to negative pi. What's the sign of negative pi? 0. What's the sign of negative pi over 2, or negative 90 degrees? Negative 1. And then back to 0. The sign of 0 is 0. Now, we'll rotate in a positive direction. Sine of pi over 2 is 1. Sine of pi, 0. Sine of 3 pi over 2, negative 1. And sine of 2 pi back to 0. Okay? Same thing with our pi over 4s. Shall we go? So pi over 4, by the way, remember, everybody's positive in quadrant 1. Sine is positive in quadrant 2. Sine is not positive in quadrant 3. And sine is not positive in quadrant 4. Okay? Think about that. Sine is positive in quadrants 1 and 2. All right, so in quadrant 1, the sine of pi over 4 is 0.71. Quadrant 2, the sine of 3 pi over 4. Go to quadrant 3. Right? And then go to quadrant 4. The sine of 7 pi over 4 is negative 0.71. Questions? So remember what I said about coterminals? If I start rotating backwards now, negative pi over 4, I'm in quadrant 4, that's negative 0.71. Negative 3 pi over 4, I'm in quadrant 3, negative 0.71. Negative 5 pi over 4, I'm in quadrant 2, sine is positive. And then if I go back to negative 7 pi over 4, the sine of that would be also positive. So same kind of points, right? Just in different positions on your x-axis. So let's just start at negative 2 pi. We got 0. And then at 3 pi over 2, you're at 1. And at negative pi, you're at 0. And at negative pi over 2, you're at negative 1. 0, 0. Pi over 2, 1. Pi 0. 3 pi over 2, negative 1. 2 pi, 0. And then we'll get the intermediate values in. Negative 7 pi over 2, up 0.71. Negative 5 pi over 4, up at 0.71. Negative 3 pi over 4, down. And negative 4 pi over 4, down. Pi over 4 positive. 3 pi over 4 positive 0.71. You don't need me to dictate all this. You guys got it. Right? So when we draw this, curve through all of those, try to do curves. Nice. That is not good. I want to turn my tablet sideways so I can do a better job. When I draw these curves, I'll always turn my paper vertically. So I don't know, it's just easier for me to draw curves from top to bottom than it is from right to left. But that's just me. So I like to indicate that I'm heading down, but I'm starting to curve as I towards the valley or the peak. And there's your sine function. So let's describe its features. Continuous or discontinuous? Domain? Right, because all my thetas, as many as I want. Range? Close from negative 1 to 1. Is it even or odd? Let's check. Look at this point right here. This is pi over 2, 1. And over here, this is negative pi over 2, negative 1. Even or odd? Odd. Okay? So my symmetry is across the origin. That's origin symmetry. All right? What's the period? Now, it's a little harder to see the period with cosine than it is with sine. But if we measure from peak to peak, which is the way I like to do it, the measure from here to here is 3 pi over 2. And then if I continue from here to here, that's a measure of pi over 2. Add those together. 4 over pi over 2, which is 2 pi. Okay? So sine and cosine both have a period of 2 pi. What's the amplitude? Midline to peak. 1. And there you have it. So those are just the basics. Now tomorrow, we're going to be graphing secant and cosecant. And to graph those, we need these two. And if we're feeling good, we might do tangent and cotangent. Okay? So today, instead of having you write your summary, I would like you to answer these questions. And then your homework is to graph the sine function and the cosine function over the interval 0 to 4 pi. Okay? So real quick, I just want to give you advice. When I do my graphs for trig functions, and I'm going 0, I'm going to extend this out. So I'm going from 0 all the way out here to 4 pi. So the first thing I'll do is I'll count out some even increments that I can easily cut in half, and then cut in half, and then cut in half again. So I cut 4 pi in half to 2 pi. And then I cut 2 pi in half to pi and 3 pi. And then I cut each pi in half. So that's pi over 2. 3 pi over 2. You watching me? What's the next one? 5 pi over 2. And then 7 pi over 2. And then, those are your quadrantals. You got to get your pi over 4s in. So I cut them in half. Watch. Pi over 4. 3 pi over 4. 5 pi over 4. You following the logic here? 7 pi over 4. 9 pi over 4. 11, 13. You get it? So just be really careful when you're doing those. Also notice this is a pretty long graph, but vertically it's really short. So I always turn my graph paper on the landscape to draw my trig functions. Okay, landscape instead of portrait. All right, so there you go.